Hello my friends, today I want to find the solution of a from this expression. I can write these two terms as a squared. A squared again is a 4 and 9 you know is 3 squared. So this is correct. But maybe you remember from the mathematical formulas x plus y squared is x squared plus y squared plus 2xy. This is a famous equation. By taking these 2xy to the other side, you can find out x squared plus y squared is x plus, I just exchanged the sides, doesn't matter, minus, because taking to the other side, 2xy. So this is very useful formula to use in our case, because now x is I squared and I can write it, x is I squared and b and y is 3. Okay, I can write these sides, replacement of this expression here, which is x plus y squared plus 3 parentheses squared minus 2 times 3 and r squared, which is 6 r squared equals to 0. Now it's very easy now. This is a squared term. You can write it as a squared again. A squared plus 3 squared minus, you can write it like square root of 6 r, the parentheses, to the power of 2. Because this term is exactly 6 r squared. And this form may you remember another formula. There are a lot of mathematical formula you can use from this problem or other problems. If you want to more examples, it's better to subscribe my channel. You find a lot of solutions, a lot of problems. I explain these formulas every week for you. Thank you. You can leave also your message or your comment about my solution or about your solutions. Now I write another formula here. If you have x, it's better to write and another way, x squared minus y squared, you can write it like x minus y times x plus y. It's the same case for our solution here. This whole is x squared and the second one is y. So you can, again, I can write it for you here. X is here a squared plus 3 and also y is square root of 6 r. I can replace the formula here. So we have x minus y r squared plus 3 minus 6 square root of 6 r times x plus y r squared plus 3 and plus now 6r and whole terms is equals to 0. So we have two parentheses times each other equals to 0. So both of these parentheses should be 0. And we are very close to the final solution. So We don't need this formula here. I can erase it, but keep in mind they are very important. I can erase everything. We don't space enough here. Okay, now we have two cases. The first parenthesis, now first parenthesis minus equals to 0. Or in a standard form, you can write as minus 6r plus 3 equals to 0. And you know, it's very simple to find out the solution. It's the second order equation, and you can find the solution as by delta approach. Minus b, which is that, is square root of 6 plus minus. It has two solutions for the case 1 and two solutions for the case 2. Actually, I can write it. It's this one for case 1 and for case 2. And this is our case 1 or parenthesis, first parenthesis. Now, plus minus square root of this one squared, which is 6, minus 4 times 3 and r squared, 12, 12 over 2. Okay, very simple. Now, r is now square root of 6 plus minus square root of, this is the minus 6 over 2, and you know this is a complex because we have a negative number inside the radical, and imaginary is, the definition is I as a square root of minus 1. So you have two solutions, plus minus I over 2. This is the first pair of our solution, but we have to do the similar approach for parenthesis 2. So everything is same, just about the signature. Okay, I can erase these sides. We don't need it again. Just write this second parenthesis in a standard form. I don't waste the time. Plus square root of 6r plus 3 equals to 0. Okay, you can see everything is same, just one signature are different. Okay, I can go further with this equation by the same procedure, which is r is the fraction line minus square root of 6 plus minus, but here everything is same, over 2. Now is again minus 6, but minus 6 plus minus, we can just write the imaginary number over 2. Okay, now from the first pair we have two answers here, and the second term we have two answers here, and you can see we have 4 roots, and 4 roots are entire roots are imaginary. So we don't have, it's very simple because it's very easy. You cannot find a number which can be squared and the answer is a negative number, because R4 here is equals to minus 9. It's impossible in real numbers. We have only imaginary numbers, as you can see, because the fourth order and we have to have 4 roots. If it's not real, should be imaginary. Thank you for your attention and please write your comment for me.